As the next step, now you can copy and paste the dataset into Stata Software. So you need to go to data editor and open data editor tab. Then you will have a platform like this. Go straight forward to your Excel sheet and takes this set of data. This set of data from row number 3 to row number 564. Now copy and then paste into data editor platform. Paste. Click this one. Treat first row as variable name. So because you need to have the variable names as a syntax recognized by this software. So treat first row as variable names. So you will have this form of data extract, which means here all the fonts, all the numbers are given in black fonts, which means the data set is strong and it's sweet and appropriate for the data analysis. So therefore, thereafter you can save this data file with a name as you wish, then save it, okay, in your laptop. Now you are going to analyze and run the models. Here in this, first of all, you need to define the variables, define and declare your data set. Here you use longitudinal data panel and panel data, not the cross-sectional. Cross-sectional means you will take a specific date of time. But here in this our data set, we have a number of years from 2012 to 2021. So we have, therefore we take this data set as longitudinal, which means panel data. You click this one, longitudinal data, then you set up and declare data set to be panel data. You need to declare your data set here. Panel ID variable will be company, panel ID variable. Then you need to have a time variable because this is not a cross-sectional, this is a longitudinal analysis method. So you need to tick time variable here, then choose what variable it will represent. It means here. Okay, then okay. Now you have already declared data set. Now first of all, we'll analyze a simple model here like this ESG score and board gender diversity here. Okay, for this, all the model will be analyzed in similar way, but the codes will be different from one model to another model. So basically, you have several variables under each major variable. Now let's analyze one simple model. Go to statistic. Then you need to go to the dynamic panel data. Choose number 2 of second option because your supervisor has chosen this method, this estimation method. You can even go to this one, but better we will go to this one, then you can have a better understanding. So click this one. Now as for this model, number 1, number 2, number 3, I'm going to run 3 simple models. So then you can analyze many models in the same way by using different kind of variables. First we will take ESG score as dependent, BGD as independent. All models will have control variables. Therefore, okay, dependent variable in this case will be ESG. Click drop down button and you will see ESG here. Now you have chosen dependent variable as ESG, environmental, social, governance, disclosure. So according to the first model here, we will choose both gender diversity as independent variable. So choose in both gender diversity BGD, where is it? BGD as independent variable. Here here BGD is taken as the percentage of from the total number of board, okay, board of directors. So BGD, our basic variable to represent board gender diversity. Now, as I told you earlier, we have two time frame where before 2020 and after 2020, MOVA1 and 2. Before 2020, the ESG disclosure was voluntary, and after 2020, mid of 2020, the ESG disclosure has been asked to be a mandatory one. Now you are choosing the model again, dependent ESG, independent. Now you go to by if in tab. Here, repeat commands. Click this one because you are going to analyze two time frame. So variable that define groups. So choose go to MOVA. This one, MAVO. Sorry, MAVO. Only one click. Okay. In this year, this same to this is similar to the this column MAVO. Now click OK. Now you see the results for the ESG and both gender diversity score. Now we will interpret this result. Before that one, you need to understand. So because you can't save this file as same as this because you need to create a log. That is how Stata application gives you the results. So now you know how to analyze a simple framework. Here the results. Okay. Now, but you can't have output here. So therefore, again, now the simple thing is here. You know the code here. This is the code. If you copy this code, if you copy this code and paste here, the same results, the same analysis will be given if you click the enter. You see that one? So after you define the variables, you can copy and run the models and make some changes to here. For example, if you, okay, let's take this one. Then here, if you need, this is the ESG is a dependent here. The first variable is dependent variable in this code syntax. Then both gender diversity is the independent variable. So here, if you can delete BGD variable, you can put another variable. For example, finance performance. So there are many finance performance measures here. For example, TQ. If you write TQ down here in this code, the result will be given to in relation to ESG and TQ. You see, ESG TQ. Here, ESG both gender diversity. So a simple matter of fact here. I mean, so you can interchangeably use some words and make different models like that. So I have given all those things a file called commands. This file command for all models like this. You can write those codes in accordance with the way of your framework. It's up to you. You can decide. Here ESG, you can change the name as another variable. Likewise, you can generate many variables here, like many models. All these one row, one sentence represent a specific model. So you have to go through one model by one and one by one, and then interpret the results. Here, how I will tell you how to interpret the results. For example, if you take the dependent variable as ESG, and then you will choose the both gender diversity as independent variable. So here, this is like one variable. You forgot about that one, and it is like intercept. So, but we are your two variables here, ESG and BGT. I forget to include the control variables here. I will do it then now. And so here, for example, how to interpret? Okay, this is the coefficient value of BGT. It's a -1. It's a negative. And but here's the very important things. You need to see this column, p value, probability value. If the rule of thumb is if the p value is less than 0.05, that means the model is, I mean, the coefficient or the variable is significant. There's a significant impact on the dependent variable. If that independent variable has a p-value of less than 0.05, but here 0.5, which means it is more than 0.05. That means this is not significant. The model cannot be accepted. Here we can't interpret like BGT affect ESG. Here we can conclude that there is no impact on BGT or gender diversity on the ESG because p-value of that variable is less than, not more than, above the 0.05. So always it should be 0.05 in order to take it as significant variable having an impact on the particular dependent variable. Now I will include again all the control variables as well. I forgot to include that one as well. Again, you go to longitudinal panel data, dynamic panel, option number 2. Now you only take one variable. So now I will have age. Yeah, age. Then LTLTA, total liabilities to total asset, that is called leverage. How much debt you have in terms of your assets. So that's called leverage. So you can take this variable LTLTA as the leverage. So you go TLTA. Now age has been taken, leverage has been taken. Now you have to take the size. Here we measure size as logarithm of total asset here. So LTA. So call this LTA. Go to LTA. Here. Now you have three control variables here, as you can see here, and the one independent variable here. All these variables called as into the group independent variable group. Again, variable defined by group have been clicked OK, which has to be tick. Now OK. Here the model again, the result. And here you see BGD, there's no significant impact because it is it is above the value of 0.05. P value is more than that we expected. Here age is significant because not a significant. It is also above the 0.05. Here all the variables are not significant here in this model. This is for MAVO. Okay, that means before the mandatory requirement of ESG disclosure is required. This is where mandatory requirement is there by the review law. Here is a different time framework. Here it says BGD is significant. It is 0.05, less than 0.05. It means p-value is significant. It means the variable is -1. Therefore, there is a negative impact of both gender diversity on ESG disclosure. That's a simple model. Okay, so it can be accepted, but you can't directly accept this one because there are many variables to be considered as well. Here, because you need to go one by one, then you need to understand those things because there are some rule of thumbs to run the models in terms of mediator and moderator. So therefore, these are the basic understanding how to interpret results, right? Always in here dependent variable. These are independent variable. Okay. Independent variable include here BGD and the other control variables. Now you you can't save directly these output. So as I said earlier, you need to go to first. You need to make a you need to make a log begin. So you save this one as a log, as a log file, and save as a name whatever you need. For example, I will type here like this, and log has been created. Remember that once you create the log, then you have to run the model. Then only they will save those things. Before the log is created, these are not saved on the draft. I mean on the log file. Now you are going to run the model again and save it to the log file. For example, if you run this model again, so as I told you earlier, you don't need to go to one by one. So just copy this one and paste here. Then log has been created. Now you have to close the log in order to save this file. You can create until you think that it is okay to finish this work, then you close that one. I will close here. Now you can have that file name like, I can't remember where it was free. Yeah, here the log. Here is the log that we created now. The results are there. So likewise, you can develop many models, run them, and save the output as a log here. And also, please remember, so we have only analyzed those data by using two frame, Marvo 1, Marvo 2, but we have not analyzed the all period as one. I mean, even before and after the mandatory requirement was enacted. That means from 2012 to 2021. Here, Marvo 1 means before 2020, Marvo 2E means after 2020. So, by taking all these into consideration, we can run as a one model, single model here. So, yes, it's very easy. Just copy here, then paste, then delete this area. So this code stands for to differentiate time frame. You delete this one. Categorization. This is a kind of categorization. You delete this one. Just keep simple code like this. If you need to go to the step like this, and you can do the same thing as I told you earlier, but better if you copy and this and paste, the model will be there for the all model. I mean all years. Now see, there are the results as a one model. Here there is no time differentiation between MAO 1 and MAO 2. This is for the all period from 2012 to 2021. Here we can interpret the result. Here age is as a control variable. Then age of the company is significant here, which means p-value of that one is 0.01. 0.01, which means it is less than 0.05. It is significant. But these three are not significant. When you interpret the result, don't go to interpret this one. Don't go to interpret this one. Only interpret in variables in between them. This is like one means that like intercept, you don't need to understand that one. This is a constant, so that also don't need to be interpreted. Only you need to interpret your dependent and independent and then control variables. So likewise, you can change the syntax by changing these things. Also, you can run this one. Now, for example, here we have taken ESG as dependent variable. Now you know, as I told you earlier, ESG has another types. There are three types of the ESG scores: government, environment, social. So you can, these are the syntax, the codes like shown here: government, environment, social. You can run one by one here. So instead of ESG, you can type GOV. Instead of ESG, you can type here as the code GOV. Let's see what happens. So now instead of ESG, now here you can see the governance score as the dependent variable instead of all ESG score, right? Likewise, you can put as you can put environment code. That code has to be same as given in the here, okay? And environment. So even you can write this. Now you see environment. So likewise, you can change this to as social source and run. You see, instead of ESG, now you see the social dimension as the dependent. You, instead of ESG, you can see the environment as the dependent. Likewise, you can change these codes. So therefore, it is better to open a file like run like making code like this. For example, like this, then you can run by, I mean, here you can say ESG, here environment, here source, and here government instead of environment. So now we are going to analyze the impact of bond gender diversity on ESG scores. This is one model. You can even see the result. What about if you change ESG into environment only? Then the code will be like this, environment. There's another model. Likewise, social, likewise, governance. But all these are for the all period from 2012 to 2021. Now you need to change. This is particular model, ESG on BSD. Okay, if you go to this one, you see the when you differentiate the time duration, we use this code we had earlier, like this. Okay, then copy only the fonts. Okay, from here to here, copy. The same code will be there as long as you take specific models and with different items. So same model here, ESG, BGD, and control variable same there. Also here, this and this and these two are similar. What we have changed here by MAVO, there are two specific time frame before 2020 and after 2020, MAVO 1, MAVO 2. So we can sort these model by MAVO then. The same thing is here. Then sort, then instead of ESG, we can see the environment. Here environment for two different types. Like this. The result will be given like this.